Excellent, and welcome to the TADSummit online conference. I am very happy to introduce Vance Shipley, the father of Erlang. Well, at least a man with a lot of relevant experience. So we've had quite a few questions come in from people that have wanted to learn more about what's happening with Erlang in the AI space. But Vance, please introduce yourself.
Hi, well, I'm Vance Shipley, CEO of SigScale. SigScale is a open source software company for targeting the phone companies.
Yeah.
But I got into Erlang years ago, many years ago, 25 years ago, when I started another company, and that was Motivity Telecom, and similar sort of focus though that we providing software solutions for communication service providers, and I sat down. I had a new office, new desk, and I really wanted to do this right. So I'm you know this is what we're here for. This is the mission. We're only doing one thing. We're building software for service communication service providers.
Yeah.
So what do I need? Like what's the best tool for the job? And I uh, I'm not much of a, or at least then wasn't much of a computer science person. I'm actually a high school dropout,
Oh,
and
wow.
uh, started working in the cable television industry when I was just before I turned 16 years old, and
Yeah.
then went into the interconnect business, telephone business, and have been in the phone business ever since. But
Gotcha.
anyway, at that time, like I understood the phone business, right? And what are the characteristics here? Well, the characteristics that are important there, that we're developing things which really revolve around communicating finite state machines. So that was a little bit of computer science I learned at that stage, right? Okay, so I understood really this is the thing I need to do well. There's other things I'll need to do, but this is the thing we need to do really, really well.
Yeah.
What's the right tool for the job? And I had tried some other things. There was a sort of a DSL type thing, which templated C code, and I liked it. I was using it, but the one thing that it didn't do was concurrency, right?
Gotcha.
Like because yeah, so that's a fairly easy way to express a finite state machine and manage it. Uh, but I need like 10,000 of those running at the same time and not in parallel
Yeah.
concurrently, meaning they're
Yes.
all in different states, receiving things at different times. And so, what's the right tool for the job? And my research um, told me about something that was going on at Ericsson,
Yeah.
right? And Ericsson are one of and still today one of the major suppliers in the telecommunication world.
Yeah.
And they had developed this thing called Erlang and the Open
Mhm.
Telephony platform. And I read a bunch of research about it. It had been going on for a number of years, and I found out that you could license it from Ericsson. So I did. It cost me, I think it was about $10,000 at the time for a
Mhm.
1 year license, and I figured this was worth doing it, right? And
Yeah.
I'm gonna get what I really really need, and so I did. They sent me a bunch of hardcover books and a big contract, and I got the software. And then I started writing code, and um, it turns out they released it open source 6 months later, and so I was looking at my glass trying to decide whether to be happy or sad about that, and I chose to be very happy about it because
Yeah.
I was never going to have to pay that again.
Exactly.
So, and I never have, and I've been using it ever since as my primary language.
Cool.
And I'll tell you, the experience was rewarding right from the beginning. The first thing that I did, I had a I had a customer, and they needed, for some complicated reasons, they needed to generate a huge amount of traffic of telephone calls,
Oh,
and they should be stochastically random so
yeah,
that so that it looked like
yeah,
really normal kind of traffic,
exactly.
and to just generate as much of that traffic as possible. And so, and I was well, so I wrote the finite state machine for this phone call that needed
Yeah,
to take place, and I had a signaling solution which drove the events into it,
yeah,
and then OTP will allow you to just automatically instantiate all these
yep.
things as you need them, and they come and
Okay.
they go through supervision, right? So you've got the you're writing just the callbacks for that finite state machine. The rest of it is handled by the platform, the eventing and all of that. And then the concurrency uh, is handled by supervision. So you
Yep,
define a supervisor, and and you create new instances.
yep,
Um, and and so it wasn't very difficult problem. I in a few days I wrote that and we launched it, and worked late into the evening, and got the thing going, and there it was, and it was filling up the pipe with all of this traffic, and everybody was happy that we got it launched. And I went home, and I came in the morning, and I started looking at it, and it's still running.
yep.
Everything's fine, exactly the way I left it, really,
Okay.
just chugging along. But I started looking at the logs, and I was horrified that they were just filled with errors, all these errors going in the log. And oh my God, what's going on? And it turned out every single one of those FSMs was crashing. But because it's Erlang,
Yeah.
the supervisor put another one in place, right? And it kept going on. Well, it turned out that it was only crashing during the teardown of the call. So
Okay.
from a customer's perspective, it was fine, right?
Yep.
Like they didn't even notice. So that was my first experience with it. Is like
Wow.
this thing worked. It even though it was wrong from the beginning, it just
It worked.
handled all this load, didn't break a sweat, and and there we were. So I was pretty
Oh,
happy with all of
wow.
that.
Yeah, yeah. So you were doing testing of systems. So this was creating traffic volume to see how systems coped with volume. Was that? Oh, I'm just trying to understand the purpose of.
It No, it wasn't. It wasn't even that. In the global telephone network, you've
Yeah.
got multiple operators, and
Yep.
operators have settlement arrangements between them, and
Yes.
sometimes it's bill and keep, and sometimes it's something else,
Yeah.
and sometimes, when you've got new competitors that the
Yeah.
regulator has put a regulatory framework in place, that you have to deal with them even though you don't want to. Anyway,
Gotcha.
so that's the whole and there's these kind of loopholes and all of that, right? And so if you don't have if your traffic is imbalanced,
Correct. Yeah.
then you can start to be penalized for that,
Yes.
right? So you want to keep the traffic balanced the other way.
Yeah.
So the operator just wanted to get all this traffic
Gotcha.
flowing.
I understand. So hey, we're reciprocating the traffic. See, we're passing back all
Yeah.
this traffic to you. Gotcha. But it was fake traffic. But and that I think is such a great example of it was, it was failing, but it just kept on running, which you hear
Mm.
so many stories of the power. Slava, I mean, we have you on the line. Do you have any questions for Vance?
Yeah, basically, I had the question regarding the six scale. Actually, what exactly you try to provide for the customers itself? I mean, what the services your company are provided. So yeah.
Yeah, so I founded SigScale 10 years ago, uh, and uh, just 10 years ago this year, yeah. And I was starting with all of this library of code that I'd written over the years. And so at Motivity Telecom, which I ran for a dozen years, which was I just described sort of the beginning of that.
Yeah.
And we created all this software. It wasn't open source. So that I was doing it under a different model, the sort of more conventional model. But I'd written a lot of code around signaling, right? So SS7, ISDN, and a lot of stuff like that. And so, and then all this know-how with around Erlang and OTP and et cetera. And so when I started SigScale, the name means signaling at scale, right? And my idea about this was I don't want to go out and get a whole bunch of venture capital and spend it all on hiring sales guys. I'll do open source. And the reason I wanted to do open source is simply because I wasn't going to invest in a sales channel. I was going to do the if you build it, they will come model, which is kind of a crazy thing to do, but it worked, right? And you publish stuff on GitHub and people will just sort of discover that there's an open source version of the thing that they otherwise have to pay a lot of money for, and they will want to know about that. And so I've actually managed to do this for 10 years now. People call me. I've never made a cold call. And so that was that plan. But I wanted to do the same sort of business targeting communication service providers because that's my know-how and that's where all this intellectual property that I've developed went. So I open sourced everything that I had already. Which included the full SS7 stack, right? So okay. we've got TCAP, which was a really big project, and then CAP on top, the Camel application part on top of that, mobile application part. There's one of the things about Erlang OTP, it has an ASN.1 compiler, right? And it's a good one. And so it's a very mature one. It's used by Ericsson,
Yes.
And so you take the ASN one for the mobile application part or ISUP or CAP, and you run it through and it does code generation, and then you've got your codec. Your codec is built for you, right?
Yep.
And then all you have to do, it's a big all, but all you have to do is implement the procedures.
Gotcha.
And all of that stuff I just love doing because I would get the standards. I'd take the ETSI and 3GPP standards, which were so well written and so concise, and there, like, those are your instructions. All you need to do is implement it, right?
Yep. Exactly. No, absolutely. So did you? Because one of the challenges with standards, especially when we start veering over to IMS and IP multimedia subsystem and RCS, is there's a lot of complexity hidden in there. So if you're not in the meetings where the standards are being written, it can be, like there's a decode problem. So I'm just interested, was it just right timing where the standards were being created? It was all around SS7, so it was clear, not relatively easy. You needed to have that specialism. You needed to understand what the hell they were talking about. But there wasn't the complexity that we see in standards today.
Oh, no, absolutely there was.
Okay.
And, all the protocols then were binary.
Yes.
And then we went through this phase where everyone lost their mind and everything had to be text. Right, because the web worked, and it's text, so therefore everything has to be text, and we're only just now getting over that.
Gotcha.
Right, we're doing HTTP2,
yes.
and we're going back. We're gRPC, and we're going back to that. Right, like gRPC, that's ASN.1 all over again. Right?
Exactly. Exactly.
So anyway, they've always been complex, but because they were well-written standards, not just de facto standards. They're written by
Understood.
standards bodies. They're written
Yes,
by people's full-time job is to
exactly.
do specifications.
Yes.
And so they're really very implementable,
Yep.
and the all of those arguments have well, probably not all of them, but many of those arguments have already taken place,
Yeah.
and they've put out a new version of the spec, right?
Gotcha.
So you've really got a running start.
Yep.
Having said that, most of the business that I did at Motivity was creating interworking functions
Yes.
where this on this side you've got one requirement on the interface, and on that side you've got another requirement on the
Yeah.
interface, and they don't quite line up.
Yeah.
Like,
Ericsson did it different to Alcatel-Lucent, you know?
well, a lot of it was things like international variants. So
Yes.
if I'm taking a switch in New York and trying to connect it to a switch in Italy,
Yeah.
now the way that's normally done at the time is you would both go up to an international switch, and
Yep.
you'd talk the international ITU-T,
Yeah.
and that's agreed on at the global level.
Yeah.
But that's a heavy investment, and if you just want to get your traffic over there, you really want a solution where your ANSI switch can talk to an ETSI switch, and you've got to line those things up, and so I would put an interworking function in the middle and do that, right? And what was the interworking function? It's a massively concurrent set of communicating finite state machines, right?
Yep. Exactly.
And so
Ooh.
OTP provides you the compiler
Yep.
to automatically generate a codec based on the specifications, and it provides you that supervision framework, and it provides you the code framework so that you're just doing the procedures, and then which are in callbacks,
Yep.
right? And then the main loop of those finite state machines all provided by OTP.
Yeah.
So you're just down to doing just the business that you need to do, and you've got a platform that does it all. And then on top of that, it does all the non-functional requirements like logging and all of that.
Yeah, no, absolutely. That's clear. Cool. So, given all the experience you've had in this space, what are some of the surprising or unusual applications you've seen built in Erlang?
Oh, they've well, this red thing, which you're going to talk about, that is one of the more recent things that I was quite interested in, and that's unusual. One of the things that happened with OTP, so like you need to understand that Erlang is it's a functional programming language, but it runs it's a virtual machine language, right? So you have text-based Erlang code modules, and you compile them to Beam code, and the Beam code is like assembler, and it runs on the Beam machine, and the Beam machine is like a Java virtual machine, right? It's or a WebAssembly virtual machine, and OTP provides that virtual machine. It's written in C, and so OTP is the platform that's providing all of that. Most of it's written in Erlang. The runtime part is written in C, and so what people did was they started putting new languages on it, right? And so that's what Elixir is, right? So most people have heard of Elixir these days. It's kind of overshadowed Erlang. I've never done much of anything with Elixir, but that's because I'd already, 15 years of
Yeah.
Erlang programming behind me. So I wasn't really the target market, right? But
No,
that's
not
fantastic. But we've got other examples of that. There's multiple languages that are targeting the bean now, right?
Yeah.
And we've Robert Verning, one of the original fathers of Erlang, wrote a Lisp
Yes.
for Erlang, right?
Yeah.
And that's fantastic. I wish I had enough spare time to play with that.
I know, and the headache tablets as well, because Lisp isn't the easiest language to work with. But Slava, I heard you trying to break in there.
Yeah, I just want to mention that regarding the Elixir itself, that you see the Elixir itself initially, well, at least how it's used in the real world. For example, I was saw that it's amazing, suitable for the web stuff, like for the websites, for the web
Yeah.
services itself.
Yeah.
But when we talk about some, native stuff which are related to the, let's say, to the telecom, or from the some specific stuff which are related to the IOT itself, any or mostly all, let's say, the Elixir projects are trying to use the Erlang inside of them, because the initially Elixir was not developed for the similar stuff. Yeah, they are trying to provide a lot of interesting stuff, like I don't remember, like. Uh, Live book. This is something like the similar to the Python notebook, I believe.
Oh,
It's
okay.
like when they can run it at the same time in the page, web
Yep.
page, some scenarios of the parts of the code. So, yeah. In any case, I believe that. The Erlang, as once mentioned, that a little bit is shadowed by the similar new languages, and for the newcomers, and who is wanted to try to go into the BIM world, let's say,
Yes.
or the Erlang world. But in any case, when will be need to go in deeply, and you will be need to get the performance itself, and some integration with the native stuff, then you will be, in any case, need to learn and use the Erlang itself. Yeah.
Gotcha. Understood. Understood. So Jonathan it's atomic. It's, the whole AI stuff. So Vance, just interested, given your purview, what you're seeing around AI and Erlang.
Not a lot,
Gotcha.
honestly. I don't have a big interest in AI myself.
Hmm.
Uh, I'm anticipating in the future
Yeah.
it'll be applicable at something, but I wasn't jumping on the bandwagon
Yeah.
and heading off to the gold hills. So I don't have a lot of direct experience in it.
Yeah.
But looking around, I haven't heard a lot in the Erlang community
Yeah.
around that particularly. Um, I'm not really sure where you would find those synergies and sweet spots sort of thing.
Yeah, no, absolutely. It was like, it was a pet project for Jonathan. So he was just interested to see, am I working, am I outstanding in my field, working by himself, or is there a community? Because that's always, with open source projects, you all of a sudden you discover, there's these people working on it, and then it's like, I have felt your brothers, So you always do that search to find, has somebody been here before when you're working on an open source project. So Jonathan was
Yeah,
doing a
Yeah.
sample search. But Slava, what are you
yeah.
seeing out there?
Yeah, regarding this stuff, well, basically the Erlang is already used in the some telecom, let's say, companies,
Hmm.
which are trying to use the AI itself. So, but when we talk about the Erlang OTP, it's not, Erlang HTTP is not about the building the AI model itself.
No.
So it's about the handling of the millions of the live sessions around the model, like the
Yes.
connections, retries, timeouts, queues, prioritize, and the CLA, for example. And models can be run in the Python, Rust, or Golang
Yep.
without any problems. So the Erlang itself makes sure that the traffic and the requests are managed reliably
Yeah.
itself. So yeah, and here where exactly the Erlang is shining, and here exactly how it can be the solve of the and the integrated with the AI projects itself. So yeah.
No, absolutely. Because I'm seeing a lot of because spam, robocalling, it's a daily occurrence as a telephony user. I've got basically crap coming in on my phone, numbers I've never seen, leaving voicemails that I have to listen to, which is like, fake voices. And I'm glad so iPhone, Apple does the launch. It's we filter spam SMS. It's like, well, yeah, Google's been doing that for as long as I know. Why weren't you doing that already? It's like I look, oh my inbox is full of spam, and then you look over at your spam and filtered, and it's like, oh, that's where it's all going. So there's a lot of interest in just trying to make the PSTN less noisy. And I think that's where we're seeing, a discussion, a sort of, what's the best way to solve this? Because it is expensive, it's intense. And as always in the telephony world, you're being asked to do more with less. So I'm just seeing a lot of companies struggling in how can we improve the telephony experience? Customers are complaining. I mean, here in the US, the attorney generals of every state are bemoaning. We saw in Texas, they created a new law where, hey, SMS are beholden to exactly the same TCPA regulations, because it's marketing messages. I don't care whether it's on text, SMS, or whether it's coming in as a call. Customers need to be treated with respect. It's disturbing them. So it's interesting to see a lot of energy, but I think there's lots of discussion happening around how best to solve that. So that's part of why we're seeing the discussion around this topic. And it's not necessarily everybody chasing after the gold hills. It's like, we have an AI project.
You mentioned resources, though. And this is one of my biggest concerns about AI is just what's the energy cost?
Yes.
What's the cost on the environment? What about the depreciation of all that? It just seems like we're currently in a period of enormous destruction of wealth.
Correct.
That's just like, it's just being thrown down a hole, really.
Yes. Yes.
And I contrast that with our experience with Erlang and OTP. So I build these systems and they're entirely Erlang. So all of there's no dependencies, right? It's Erlang.
Yeah.
And the only time I end up having to introduce dependencies are for like the web front ends or something like that, right?
Yeah.
And Erlang is not only a concurrency-oriented functional programming language, but the OTP platform, it provides all these standard libraries. Erlang is also distributed, right? So when we say it's a concurrency-oriented programming, what that really means is that built into the language, there are language primitives for communication between processes, right?
Yes.
And those processes can exist across a distributed cluster of Erlang nodes, right? You could have hundreds of these, and so that's the environment that you get. Now, one of the most important applications in the standard library is Amnesia, and Amnesia provides ACID transactions across the cluster. And it's not a database in the classic sense. What it is it's based on Erlang term storage. So you've got some Erlang terms, and it can be anything. It could be a PID, or which is a process identifier. It could be a fun, which is a functional. It's a piece of code, right? Everything is a term, and you can put any term in the Erlang term storage.
Yes.
And so, it's very structured so that we've got ETS, which is just straight Erlang term storage. So that's just like on the one node, but you can, different processes can use the same storage. And then there's a DATS, which is a disk-backed version of that, and then you put transactions on that by adding in amnesia, and you can have RAM-based tables, you can have disk-backed tables, you can distribute your tables across a selection of nodes, etc. So all of those capabilities build on each other, but it's all so lean and mean.
Yes.
So I build. Like, I take one of our flagship project as an online charging system, and we'll tell customers, just for fault tolerance and resiliency, you want to have more than one node. So I recommend like anybody put like 3 nodes up. And people assume that means that they need to buy 3 servers with 32 gig of memory, and I'm like, no, don't do any of these. Make them all very small VMs, right?
Yes.
And what are the requirements? Well, the starting requirements are extraordinary, though. So I've done some benchmarking of our OCS using GCP's smallest virtual machine, which is actually deprecated now, but it's 684 meg of memory, and one virtual CPU, which is like a fraction of a normal CPU power, and then just put 3 of those out, and see how many transactions per second you can get on it. And then in my spreadsheet, I have a column which shows the monthly cost, $4. Here's a bigger one, $7, right? And look how much you can get through. So that's sort of what you can get out of using such a direct solution to the problem.
Yes. Oh yeah. And I see it in, here in the US, the electricity bill, because it's massive power requirements going to data centers, and of course policies that are using non-renewable resources. So it's using the most expensive power sources for powering those data centers. So it's a crazy situation, unfortunately. They're resulting in, well, fortunately, I've not had the AC on for the past few days, so I'm not feeling the pinch with the bill, but it's a crazy situation we're living in. So I'd just like to wrap it up because we're coming up on time. Slava, again, thank you so much for the introduction to Vance. Do you have any final questions?
Basically, I have some of them to the ones which they are related to the open source project itself. So we had and see that a bunch of the useful and real cool Erlang projects, open source projects in the SigScale repository and the GitHub organization itself. But in your opinion, which open source projects are still missed for the telecom community today, which are need to still need to provide more time and law maybe for the creating them for the open source itself?
Yeah, well, if you're going to start something new, you don't really want to do one of the legacy requirements. There's a lot of the legacy requirements, all kinds, but the newer ones, the things that are part of 5G core standalone core network, there are open source solutions for a lot of those things, but uh, the stuff like policy management, not so much. But even like I wouldn't say that that there's no use in replicating the things that have already been done, because they haven't necessarily been done to. Most of the open source solutions for the 5G core would never be used by a serious provider. They're used in the labs. They're used in uh, 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 rural applications, or very small companies trying to get the cost metrics to work. It's
Exactly.
nice that we can do open source now and create a workable telephone core,
Yep.
telephone network core, which we were never able to do before. And then that sort of changes the economics. So I mean, it makes it possible to roll out 5G to a little Irish island, you know. So that's cool, right? But the next thing really is to get those things to be serious contenders for large scale networks,
Yes.
and
Yeah.
I'm sure the people in those projects would wouldn't like the characterization so much, but I think it's a great opportunity for Erlang, because one of the things about Erlang is that it was first sold to me when I first approached Ericsson as a rapid development environment.
Yep.
That's really how they were characterizing it, and it's absolutely true. And people in the community have demonstrated this time and time again, that they've used it to build a prototype, and then that prototype just evolved into the production system because it
Yep.
just works.
Exactly. And this from the telco side, the prices they're having to pay as they're trying to roll out 5G SA, it's painful, and
Mhm.
the budget isn't there. So yeah, I think there's clear market need, but as you say, it's a confidence issue. Yeah, in having experience in, yes, this is open source, but it's working as good as basically the stuff we've paid 5 million for in that particular data center. So I think that there's proof in the pudding, but definitely I think to deal with the challenges the telecom, the mobile operators are facing, Erlang has great opportunities to really reinvent the cost basis for putting in your 5G SA core. And of course, coming up, 6G.
Well, the good news is 6G isn't really that much of a change. It's not a swap and replace. So we're
No,
gonna keep the same core. It's some changes in the radio access network. I wouldn't worry about
yeah,
it. It'll be
yeah,
it'll be
yeah,
fun.
yeah. Cool. Slava, any other questions?
Yeah, just the another one is, do you know when some we know that we are working with the different projects and that we are signed with NDA, etc. But in any case, maybe you are comfortable to share some the which telecom operators are use the Erlang open source projects in the production itself, and which challenges they face out when they are just take the existing solution like you provide, for example, they just try to hack your or try to read documentation, build it all their stuff by their side, and yeah, what the challenges they can face out, and can you provide some names of the those operators? Yeah.
Well, WhatsApp was built on Erlang,
Yep.
right? Um, RabbitMQ is built on Erlang. There's a number of really big projects that are built on Erlang. The operators, one of the Ericsson use it, right, for their equipment, and sort of they come and they go a bit with that. But their ATM switches were all run on with the core control being Erlang. That's one of the early success stories there. And so BT deployed a massive amount of that stuff. So really, Erlang was running in the core of the BT network everywhere.
Yeah.
And O2 back in the day, now O2 have gone through mergers and acquisitions. I don't know who they are anymore, but they did a lot of internal development. They had a core Erlang team who were really strong, and a lot of that was done there. So there's a bunch of operators like that. I generally don't like to name names with my customers, but they're you would know the names. I worked at I was a CTO at WaveNet for 8 years out of Sri Lanka. They make vast equipment, so we like SMS service centers, and so that was all Erlang. It was all based on Erlang. It was based on the SF7 stack that I originally wrote at Motivity. And that was that moved every single SMS in Vodafone in New Zealand, right? Like their whole network for years. Not currently, apparently, but it was another example. There's people don't brag about these things, but they're there, right? They're they're running these things.
But it's a cultural thing. The fact that you quote WhatsApp and it's like there's a Keystone customer and it's running on Erlang in the web community. Open source doesn't have the taint. It's not seen as, well, that's open source. It's like, yes, that's what the web's built on. We survive by that. That's what enables our business model. So I know it's a cultural issue, but there needs to be a willingness to share. Because, I have one-on-one conversations with telcos all around the world, and it's amazing. At TADSummit, sorry, we get great presentations. I first learned of Erlang from a Play in Poland presentation. So they were presenting on what they're doing and how they were using Erlang and all the great work that they were doing there. And it's that sharing we need to see more of in the industry, rather than, oh yeah, we don't talk about that. It's open source. And it's like, no, it's been proven, it's been tested. You've got some of the greatest minds protecting this. It's not something that anyway, enough ranting. Open source. Telecom industry should be proud of its use and in its network. But anyway,
the open source terminology sort of got a bad rap in the early days because there's a real big difference between when I say SigScale is an open source company, I mean we're creating software and choose to make it available really open source. Yeah. But a lot of people are open source companies in the sense that they're getting all the free software they can and then selling you a solution, right? And that's where you get asterisks and these substandard things.
Oh dear, knowing people in the asterisk community, I can imagine their reaction to it. But I've seen a large vendor implement a project, and it was using oh god, I've forgotten the name of it now, but it was an open source project, and that open source project was being approached by the telco asking for help, and they were like, okay, but they've not agreed with us in terms of doing this for a commercial deployment. So it was like, turn on the quiet, shh, don't talk to anybody. And that was because it has, the full S7 stack hidden away in there. But yeah, it's, it shouldn't be, there needs to be more openness because the whole 5GSA core, it's, the prices are crazy if you're getting it from the duopoly, because it's now a duopoly. Okay, you can include Samsung in there, but it's, Ericsson, Nokia. That's for most of the vendors that are out there. So anyway, this has been very insightful. Learned a lot. It's been great to talk, to understand, how your business began. And I just love the story where I saw all these logs and there was all these errors. It was crashing. I was like, but it's running. Where's your problem? That is just such a great example of the power of Erlang. Thank you so much, Vance.
All right, nice talking to you.
And thank you, Slava, for making this happen.
Thank you.
Slava.